Welcome to MRL. This is the third part of study of number lines. Now in this part we will be learning about real numbers number line. A horizontal line which represents real numbers is a real numbers number line. Real numbers include both rational numbers and irrational numbers. Rational numbers have terminating and non-terminating recurring decimal expansions. Irrational numbers have non-terminating and non-recurring decimal expansions. A real number line represents both the rational numbers and irrational numbers. So let us learn how to represent the real numbers on a number line through examples. The method followed is known as successive magnification method and the geometrical method. So now let us learn the first method, that is the successive magnification method of representing real numbers on a number line. Let us consider an example 2.665. 2.665 is a decimal expansion. It is a terminating decimal expansion. It represents a rational number and also it's a real number. Now to represent this number 2.665 on a number line, that is real number line. Now first step is draw a horizontal line, and since 2.665 lies between 2 and 3, mark 2 and 3 on the number line. I have marked the 2 and 3 on the number line. Now make 10 divisions or 10 equal parts between 2 and 3 and locate the division, that is 2.6 and 2.7. Now take points 2.6 and 2.7 and magnify it. So when we magnify it, we get a number line which represents 2.6 and 2.7, and between 2.6 and 2.7 make again 10 equal parts and locate 2.66 and 2.67. 2.66 and 2.67. Now again magnify this part, this portion of the number line 2.66 and 2.67. We get a number line which represents 2.66 and 2.67. So these are the 2 points which represent 2.66 and 2.67 on a real numbers number line. Again divide this portion into 10 equal parts between 2.66 and 2.67. Divide it into 10 parts and locate 2.665, which we wanted to locate on the real numbers number line. So the point P on the real numbers number line represents 2.665. This method is known as successive magnification method of locating a real number on a number line. Remember that. Let us consider one more example. That is, let us say we want to represent 5.37 bar on a number line, and if you look at this number 5.37 bar is nothing but 5.37777 ... which is a non-terminating recurring decimal expansion, and which again represents a rational number, and that is also a real number. Now to represent this number on a number line, the procedure is the same as we have learnt earlier. That is, first draw a number line and locate 5 and 6, the points 5 and 6 on the number line, because 5.3777 ... lies between 5 and 6. And after locating 5 and 6 on the number line, divide the portion between 5 and 6 into 10 equal parts and locate 5.3 and 5.4. Now take this 5.3 and 5.4 portion again on a new number line. Again magnify this 5.3 to 5.4 portion and divide the portion between 5.3 and 5.4 into 10 equal parts. Now locate 5.37 and 5.38. Take point 5.37 and 5.38, magnify it, and we get another new number line between which represents 5.37 and 5.38, and the portion between 5.37 and 5.38 is divided into 10 equal parts, and the two numbers 5.377 and 5.378 are located on the number line. Now the number 5.37 bar is located between 5.377 and 5.378, and therefore take 5.377 and 5.378 on a new number line and divide into 10 equal parts and locate 5.37 bar. So that is how the point P on the real numbers number line represents 5.37 bar. So that is the method of representing the non-terminating recurring decimal expansion, which is also a rational number and a real number. Remember that.